Okay, students, can you able to see the screen?
Yes, sir.
Right. Let us discuss 5.8. So earlier classes, as we discussed that about the role-less mean-value theorems. Okay. So there are how many theorems are there? There are two theorems are there that we know very well, right? So mean value theorems. There are two mean value theorems. In that, first one is role-less mean value theorem. Second one is Lagrangian mean value theorems. First one is Rolle's or Rolle's mean value theorem or Lagrange's mean value theorem. Rolle's mean value theorem and second one is Lagrange's mean value theorem. So for both the theorems, statements is same. Almost statement is same. So in previous class and last class, I have given a Rolle's theorem statement. So what are the conditions for Rolle's theorem? F of x be a given function defined from a comma b to r. We define the function from a comma b to r. Okay, is a function f of x. So here there are three conditions will be there. The given function f of x is what is the first point? Continuous in closed interval a comma b. Remember students, continuous in closed interval a comma b. Second point is f of x is differentiable in open interval a comma b. So in Lagrange's, the Lagrange's also same like okay. So whatever the conditions are there, first two conditions, the same conditions we are having in Lagrange's also. Okay. So let us see what is the first condition in Rolle's. First condition in Rolle's, f of x is continuous in closed interval. The same condition here also will take. Same condition. F of x is continuous in closed interval a comma b, and f of x is differentiable. And the third point is there in Rolle's, that is f of a must be equal to f of b. But here the third condition not necessary that f of a is not equal to f of b. That is the only difference. Coming to the 3 points. First one is continuous in closed interval, differentiable in open interval. Third condition in Rolle's, it is at a at b, the function, the value of the function will be coincide. But in Lagrange's at a and b, the function is the value of the function is not coincide. That only you have to remember. Coincide means the value will be same. F of a is equal to f of b or f of a not equal to f of b. Okay, and then after when the function satisfy these three conditions, so we discussed that then there exists a point C belongs to open interval a comma b such that f dash of c is equal to 0. But the Lagrange is here same. Then there exists a point. Then there exists a point small c which is belongs to open interval a comma b such that, but here f dash of c value should be equal to f of b minus f of a by b minus a. Is it clear? So f dash of c alone will be changed. The third point and f dash of c. F dash of why f dash of c is 0 here. So when we substitute in Lagrange's, actually Rolle's and Lagrange's will be same. Rolle's and Lagrange's will be same. But what is the difference here? Okay, so look at here. In Rolle's and Lagrange's, what do you observe? In this year, if you see that, students, if you see that, yeah, when I substitute f of a value, f of b in Lagrangian, when I take f of a is equal to f of b here, Substitute here f of a is equal to f of b. What is f dash of c becomes? Yes, the Lagrangian becomes rowless. Yes or no? F of a not equal to f of b, so that f dash of c is existed. When I take f of a is equal to f of a is equal to f of b, this numerator becomes 0. So 0 by b minus a, that is nothing but 0. So Lagrangian becomes rowless when we take it. Both will be same. So what is the statement of Lagrange now? F is defined from a to b to r is a function f of x which is satisfy the following conditions. The first one is f of x is continuous in closed interval a comma b. Same point. Second point is f of x is differentiable in open interval. Third point is here in rowless f of a is equal to f of b. In Lagrange is actually no need to write that f of a is equal to f of b. So it's surely not equal. So when we see the graphical representation of Lagrangian, already we discussed about rowless, the geometrical interpretation. In the same way, if I take that Lagrange's, I'm going to tell you, there exists a point. See here, I have written finally. Then there exists a point C. Point C may be unique. C may be one value, more than one value also. Maybe C we are getting two values, three values, four values, no values also. Okay, no values also. So if I take the graph in our previous class, like we discussed that time. See here, when I take the graph like this, now see here, I'm taking the interval from here. This is A. This is A. At this point here, B I'm taking. See how many C values we are going to get here. Nothing but, see, at that point here, the maximum, local maxima, local minimum. These points are called local maxima, local minimum. At this point, we can easily draw the tangent which is parallel to x-axis. See here? Yeah, there exists tangent, another tangent, different tangent. So how many C values were existing here? 1, 2, 3, 4, 5. There exist 5 C values here. Let us take this point. I'm taking as C1. This is C2. This is C3. And this is C4. And this is C5. C5. Actually, here also somewhere here we getting exist here. Anyhow, that value we can take as C4. This is C5, C6. Okay. So there exists here 6 point in open interval a comma b such that f dash of c is equal to 0. How can we say that C value here? C is equal to C1, C2, C3. Because at C1, the tangent parallel to x-axis. Parallel to x-axis means f dash of C1 is equal to 0 because slope value. What is f dash of C1 mean? Slope at C1. X-axis slope is 0. Then at the point C1 also, this is the function value becomes, the derivative becomes 0. Here f dash of C2 is equal to 0, f dash of C3 is equal to 0, C4 is equal to 0, C5 is equal to 0, C6. So when the tangent parallel to x-axis, that is nothing but the values are coincide. And also when the values are coincide, f of a and f of b. So f of b must be, you can take care like that, f of b value. When you draw that, okay, f of a and f of b must be coincide, then only Rolle's theorem is verified. So coming to Lagrangian, not like that. If I give the graph, it's like that. I'm going to give the graph like this. This is A. Okay, I'm going to take this point as A here. This point is B. I'm going to draw the graph like this. Okay, in that interval, can you able to draw the graph with can you draw the tangent which is parallel to the x-axis here? This is A. So the value of the function y is equal to f of x at A is f of A. Now this is a point B. If you draw the perpendicular here, this point is B, x value is B, then what is y value? Y value must be f of b. So finally, the points we are going to get here is, what are the point? This is a comma f of a. This is b comma f of b. That's all. See, here f of a is not equal to f of b. F of a not equal to f of b. If you take any, you can choose any point in between a and b, any point, anywhere. The tangent should not be parallel to the tangent. I'm taking the point will be here. Okay, I'm taking the point will be here. Point will be here. I want to draw the tangent at this point. Now we can draw the tangent. What about this tangent? Is it parallel to any x-axis? No. So that it is not a parallel to x-axis. So that what is the slope? Slope should not be 0 because it is not parallel to x-axis. Then what is the slope here? F dash of x, we are going to get f of b minus f of a by b minus a. If I take this point as particularly C, there exists a point C between A and B, then f dash of at x is equal to C, if I substitute C here, f dash of C is equal to f of b minus f of a by b minus a, because both will be not equal, f of a not equal to f of b. Here also we make it the values of C may be unique, maybe more than 1 point, also like this C1, C2, C3 like that. This is the graph which is belongs to Rolle's. This is the graph which is belongs to Lagrange's. Okay, students, Lagrange's. Only the thing is tangent parallel to x-axis, that is Rolle's. Tangent is not parallel to x-axis, that is Lagrange's. So what are the three points? Very easy to remember. One is continuity, continuous. One is differentiable. Another one is f of a is equal to f of b. F of a not equal to f of b. That's all. So these are the statement. So when the function satisfying these three conditions, we can say that the role is satisfied the given condition. Then only you can take this condition. See, student, when the function is satisfied, the above three condition, then only you can take f dash of c is equal to 0. If the function is not satisfy any one of the following above conditions, you should not take f dash of c is equal to 0. Any condition is not satisfied, simply we can write the Rolle's theorem not applicable, the Lagrange's theorem not applicable. Okay, like that we can write, we can stop it. For example, if I take the function as greatest integer function I'm taking, for example. So f of x is equal to greatest integer function. I'm taking the interval as 1 to 3. Is it continuous function, greatest integer? Is anyone? Is it continuous? No. It is not continuous at every integer because it is jumping from one value to another value at every integer. So it is not continuous. Okay, not continuous at 1, not continuous at 2, not continuous at 3. See, first condition of the Rolle's and Lagrange's is not satisfied here. First condition itself failed. Here no need to check differentiability, no need to check f of a is equal to f of b. The first condition of the Rolle's theorem or Lagrange's theorem is failed. Therefore, we cannot verify the Rolle's theorem. We cannot verify Lagrange's theorem. That's all. We can stop it. For example, in case the function is continuous, for example, I'm going to take f of x is equal to modulus x. F of x is equal to modulus x. What about the modulus x at minus 1 to 1? Yes. Is it continuous? Is this continuous, students? What about the graph? We are going to get a graph like this. Okay. So observe that clearly it is continuous. There is no break at all. But whereas at x is equal to 0, we got the sharp corner, the sharp point. This at x is equal to 0, the two lines are intersecting. This is line y is equal to x. This is line y is equal to minus x. Both will be intersecting. so that both will be having different slopes, so not differentiable. See, first condition of Rolle's Lagranges are satisfies in the given interval, but it is not differentiable. Not differentiable at where x is equal to 0. And also remember, is x is equal to 0 is belongs to open interval -1 to 1 or not. Differentiable we can check at the open interval. Is it clear? So clearly x is equal to 0 belongs to the given interval, and x is equal to 0, the function is not differentiable. We are getting sharp corner. Okay, two different slopes. And but if I give the same function modulus x, but interval I have given like a 1 to 10. 1 to 10 I am taking interval. F of x is equal to modulus x, but interval is 1 to 10. Now, can anyone tell that is it differentiable? 1 to 10. If I take here, it is 1. Okay, here it is 1. Here it is 10. Yeah, this is the graph of the given function y is equal to modulus x. Now, is it continuous among 1 to 10? Is it differentiable at any point?
Yes.
It is differentiable everywhere from 1 to 10, because see, the thing is, it is continuous. For example, we are saying that f of x is equal to modulus x is continuous -1 to 1. The meaning is that you have to check continuity at -1 as well as 0 as well as 1. Not only that, between that value, every real number you have to check. Don't be check that only at -1, 1. You should check at each and every point in that closed interval, including endpoints. But differentiable, no need to check at endpoints. For example, if I take the function same f of x is equal to modulus x, I want to check whether it is differentiable in the interval 0 to 2 or not. Now, is it differentiable among 0 to 2? Same function I'm taking here. Is it differentiable? Say differentiable in open interval or closed interval? Open or closed? That is important. Open. So you take open interval 0 to 2. If you take closed interval, what will happen again? At 0, closed interval means 0 is belongs to that interval. 0 clearly belongs to interval. So at 0, clearly it is not differentiable. That we know very well. But when I take open interval here, 0 does not belongs to the interval. So that at 0 alone, the function is not differentiable. But we are taking the closed and open interval. So clearly the modulus x is differentiable open interval 0 to 2. Okay. So greatest integer function is not continuous at every integer. Whenever it is not continuous, then it is also not differentiable. Not continuous means always not differentiable. Okay, remember that. And we discussed here greatest integer function, modulus function. Modulus function continuous everywhere. Continuous everywhere, but not differentiable at particular point. Okay. And coming to any other function that in last class I already we already discussed about a few functions like f of x is equal to tan x, or f of x is equal to cot x, or f of x is equal to secant x, f of x is equal to cosecant x. So is it tan x is continuous everywhere? Yes. If I give the interval, like the interval is 0 to pi, is it continuous? Tan x is continuous 0 to pi? Anyone? What do you understand? Continuous, differentiable. To check that, simply remember that when we substitute the value, when you substitute the x value, it should not be infinity. That's all. It should not be infinity. Then we can say it is continuous. It should not be infinity. That only keep in your mind. See here, from 0 to infinity, I want to check first continuity. Is tan x is continuous everywhere? Is that continuous? From 0 to 180, 0 to pi. At x is equal to pi by 2, pi by 2 is belongs to clearly 0 to pi. At what is tan 90, Amma? Tan 90?
Infinity.
Infinity. Then can we say that is a tan x is continuous? When you see the graph of tan x also, at 90 it will tends to infinity, but coming to second quadrant, it will be start with here like this. This is the graph. At 90 is here. At 90 we are having two different values. It will tends to plus infinity. Again it is starting at minus infinity to like here 0. So at 9 this is 90. What is the meaning of that? Left hand continuous should not equal to right hand continuous at 90. There is a break. It is tends to infinity when it is approaching to 90. After 90, immediately it will be starting with minus infinity. So it is there is a break. It is not a continuous curve. So where it is break at 90. So it is not because it is infinity. Infinity means undefined, not continuous. Then cortex from 0 to 180, where it is it continuous everywhere from 0 to pi? At 0 and pi. Okay, in the same way, secant. A 0 comma 5 is belongs to closed interval 0 to pi. Secant x for what value of x secant is undefined or infinity? Cosecant x. Am I right? So 0, here it is pi by 2. 0 is belongs to 0 to pi. Like that. I have given some example. So here it is not continuous. Directly these functions are not continuous. First condition of Rolle's as well as Lagrange's are failed in the interval 0 to pi. Based on the interval. First observe the function, then interval, given interval. That's all. Okay. These are the conditions. Remember here Rolle's f dash of c is equal to 0. Here f dash of c is f of b minus f of a by b minus a. Let's go for the question. And one more important point is every polynomial always continuous, always differentiable. Any interval, you can take linear ax plus b, always continuous, differentiable. Quadratic expression, x square plus bx plus c, always whatever the interval they given, negative values or positive values, it is continuous, differentiable everywhere. Like cubic, okay, biquadratic, fifth degree, sixth degree, like every polynomial is always continuous, always differentiable. Remember that. So other than polynomial, we can't say, and also we can say that sin x cos x always continuous, okay, always differentiable. Always continuous, always differentiable, because sin x and cos x, because you know sin x maximum value is +1, minimum value -1, finite values. We don't get any infinity value, so that we can say directly not, sorry, we can say that it is continuous differentiable. Here it is the function not getting any infinity, so that sin x cos is always continuous differentiable, but tan remaining functions not like that. Just now we have seen that. Okay, every note here, important note that every polynomial is always continuous and differentiable everywhere. On entire real line, every function, I mean every polynomial is continuous and differentiable. Okay, students? Right. Fine. So then let us go for the exercise. See, the first question is that verify Rolle's theorem. Verify means we have to check whether the function satisfying three conditions or not. Okay, and also there exists any point C belongs to open interval or not. That's all. That's all. Very simple. What about the given function? If you check it, is it polynomial? Yes, students. Polynomial or not?
Yes, sir.
So it is clearly continuous as well as differentiable, right? And just we need to check third condition alone. Check that here, greatest integer, not at all continuous. Greatest integer, not continuous. But x square minus 1, again, it is a polynomial. Yeah, polynomial continuous and differentiable. Next, this is general question. This is polynomial. Again, continuous and differentiable. Just we need to check. This is also a polynomial. It is continuous, differentiable everywhere. Okay. And the last exercise is examine the applicability of the mean value theorem. Applicable mean value theorem. Here they did not mention Rolle's, so that it is clearly Lagrange's mean value theorem. So we can say that Lagrange's mean value theorem, or else simply we can say that mean value theorem. Particularly they mention that Rolle's, okay, then we can apply the conditions of, we can check the conditions of Rolle's. That's all. Let it be see the first question. Okay, the first question is, see if you understood this concept, this OBT also will discuss these points only, right? Fine. The first question is f of x they given here. F of x is equal to x square plus 2x minus 8. Now, what is the given interval? Minus 4 to 2. Right now, what we have tried? Clearly, given function. Given function is a polynomial. Then first point. Then f of x is continuous. I think so. I explained this problem in previous class. Is it completed in previous class? Students, I have written directly because given function is a polynomial. Third condition alone we have to check. What is f of minus 4 students? In given function, substitute in place of x minus 4. Then f of minus 4 is minus 4 square minus 4 whole square plus 2 times of minus 4 minus 8. This is a 16 minus 16. 0. Is it right? Then f of 2. But we check that 2 square plus 2 into 2 minus 8. 4 plus 4 minus 8, that is 0. Right. So we got f of c. What we observe? Therefore, the function f of x satisfies all conditions of Rolle's mean value theorem. Then, yeah, students, when the function satisfy all conditions of Rolle's mean value theorem, then what we can write? Then There exists a point C in open interval -4 to 2. Already interval values are given such that f dash of C is equal to 0. Let us take this as equation 1. Okay, this is clearly equation 1. Okay, I want to find now this f dash of C value. What is f dash of C? Anyone? So take the given function again. What is f of x? X square plus 2x minus 8. Find f dash of x. 2x plus 2. This is f dash of x, but we required f dash of c. Then what is f dash of c? F dash of c value is 2c plus 2. So what is f dash of c equal to 0? Can I equating to 0 here? Yes. So at x is equal to c, we are getting f dash of c. I want to find c value, so 2c is equal to minus 2, which implies c is equal to minus 1. Finally, we got c value minus 1. Is minus 1 is belongs to given interval, open interval -4 to 2. You should not take closed interval. You can take only open interval, C in open interval. Is it belongs to -4 to 2 or does not belongs to -4 to 2? Yes. Wafik,
Yes, sir.
is that belongs to given interval?
Yes, sir.
Okay. Sayadar, Sayadar, Vaishnav or
Sir.
Sayadar, Trisha,
Yes, sir.
Shivareka,
Yes, sir.
yeah, Sentan Selvi, Priyadarshini,
Yes, sir.
fine. So I think so only few students, might be 4 to 5 students. When I enter the classroom, still they are in class. I called after completion of class. Before ending that, I called their names. Simply, they are not at all responding. It's simply they enter into the classroom, they are unable to concentrate. Don't do like that. Okay. You want to understand yourself, it will take more time. I'm going to explaining easiest way. I think so, right? So for some questions, see here, examine the Rolle's theorem they asked here. Actually, second question. We can say directly whether we can apply Rolle's theorem or not. We cannot apply these two questions. We can apply here alone, but here also we have to check third condition. First two conditions, okay, continuous and differentiable, but third condition we can't say. We have to substitute x value over here. F of one value, f of two value, you need to find. If both will be equal, then only we can say x square minus 1 is satisfy all the conditions, like that. First question, finally, we got c is equal to -1. -1 must be belongs to given interval. Therefore, hence we can write hence Rolle's theorem verified. Verified. Finally, we can write like verified. So if, for example, we are getting some C value here, C value does not belongs to the given interval. For example, there doesn't. For example, here we got Instead of -1, I'm getting like -6. Is -6 is belongs to -422? No, doesn't belong. In that case, what we can write? Rolle's theorem is not verified. Rolle's theorem not verified. We can't say that if the function satisfies three conditions, we can't say it is verified. First, we have to find the C value. C value is belongs to the interval. Then we can say that verified. C value does not belongs to the interval. We can't say it is not verified. Okay, sometimes what will happen? We are going to get 2 points. We are getting C value 2 points. For example, -4 to 2, one value is -1, one value is -6, like this. Here -1 is clearly belongs to given interval, but -6 is, does not belongs to given interval. In that case, we are getting 2 points. If that one point is belongs to interval, another point is not belongs to the interval. What we can conclude here is a Rolle's theorem verified, we can write, or not verified? Yes, we can write here Rolle's theorem is verified. Verified. Even Lagrange's theorem also, at least we are saying that at least 1 point. At least there exists at least minimum 1 point. Not required to that all the points C which is belongs to given interval. At least 1 point is belongs to the interval. That's it. Verified. Like that. Okay. So here -1 is clearly belongs to the given interval. Hence, the Rolle's theorem is verified. That's all. Okay, students. Let us go for the next question. Next question is, whatever we done in continuity already we have done. We proved that greatest integer function is not continuous at every integer. Okay, that we can go to that. We have to prove that. Okay, that how can you find? We have to find left hand continuity and right hand continuity at some integer. Here f of x is equal to greatest integer. The given interval is 5 to 9. 5 to 9, how many integers are there? 5, 6, 7, 8, 9. Okay, I'm taking the integer as some n. N is any integer. N is belongs to 5 comma 9. It is an integer belongs to 5 comma 9. I want to check the continuity at x is equal to n alone. N alone. So is it continuity? It is not a continuity. How can we prove that it is not a continuous? Since we know that here value we having like n, if x is belongs to n plus n minus 1, x is belongs to n minus 1. N minus nothing but n minus n plus means left hand limit, right hand limit. If I take here, for example, 2 I am taking. 2 minus, what is greatest integer of 2 minus? Lesser than 2, nothing but the value of 1.99, it is equal to 1. But whereas 2 plus is clearly 2 alone, like that. So this one can be written as 2 minus 1. In the same way, I have written that greatest integer of x, sorry, n you can take. Greatest integer of n is equal to n. X is belongs to n plus. Okay. Sorry, here we can give x alone. It is better. X is equal to n. X is belongs to n plus. X is equal to n minus 1. X belongs to n minus 1. That's all. Here we have to find LHC. And here we have to find RHC. LHC limit extends to n plus f of x. Limit extends to n plus f of x value is greatest integer of x. N plus nothing but it is equal to limit extends to n plus n. That is nothing but this is equal to n. Or next to RHC. Oh, that is this is RHC. Plus means RHC. Minus means LHC. So limit extends to n minus greatest integer function. Here you can write directly n minus 1. N minus 1. Greatest integer. So finally, here left hand continuity is not equal to right hand. Okay. N not equal to n minus 1. So it is not continuous. Whenever it is not continuous, simply we can say that it is not differentiable also. Okay. Okay, students, you can take the break. And one more thing, one more important point in the slip test. We did not give any question which is